So if you guys joining in the meantime, your audio is not misbehaving or anything. We're just waiting for a couple more folks to join if they're joining. I don't see all the attendees anywhere anyway. I just see like the few in the window, but we will give it just one more minute or less actually, and then we will get going. All right, I guess that's about it. Like we should get going. Anyone wants to do any organizational stuff before we kick things off, or are we clear to go? I'll take that as we good to go. I'll try to minimize the window in here, just so it doesn't block everything in there. Perhaps I can do this one. Oh yeah, a lot better. Now we get to see all the geeks on the screen. So welcome everybody. My name is Matouš Rokos. I'm a principal cloud solutions architect and head of cloud in a company called Powel, or Volue nowadays. We are going through a little bit of a rebranding and merging with a lot more companies. And actually my role covers everything cloud related for our company, everything that goes in Azure and other clouds as well, and the modernization of the applications, and basically like even the development of the stuff that actually gets to be nice enough to born in cloud. So this is actually our current topic. This is our topic for tonight. The cloud of modernization and how to get from cloud migration to value. You guys will get a very short sneak peek of my day-to-day life and what I do 24/7 pretty much. And I work for a software company. The Volue is a software company. We do software for renewable energy sector, primarily in Norway, where I'm normally based, and but all across the Nordics and all across the Europe as well. And we basically plan the utilization and of different power elements and grid. We do software for energy trading, and we do a lot of different kinds of things in energy. Pretty much like you name it, you can pretty much pinpoint everything there. So that's what my day-to-day life is about. And I'm also Microsoft Azure MVP for 6 years now, actually. Quite enjoying that, by the way. And so I contribute a lot to Azure directly with the Microsoft product group. I'll give them a lot of early feedback on, and then get to try the early bits and things like that. So get a little sneak peek into how things might turn out in the future as well, which is quite useful. And today I will try to share as much as I can with you in the short time given to it. Like, like on the cloud modernization and on everything, you can really spend quite a long time. And I've been actually, before I joined Volue, I was actually helping a lot of ISVs and a lot of companies developing their own software in the Nordics and in the UK to do this sort of leap, like to do the same thing, like just like go from cloud migration to any sort of cloud value. And today we are going to talk about that. So let's see what we have ahead of us. First, we're going to take a look into like, why do we migrate? How do we migrate? What do we do in the public cloud in terms of migration? We're going to talk a lot about sizing, and we're going to talk about VMs and whatever comes after that. Like we're not going to pay that much of attention to VMs because that's really the starting point. We're going to try to get to the real cloud value and what it offers. So there should be a little bit of everything for everyone in any step of that journey which is ahead of us. And we will really try to do the complete roadmap of it. I know that you guys are primarily developers, We will not have that much of like code sharing or anything like that for today. It's going to be more of a like a roadmap side type of session of what you can do. Code, of course, is a big part of that, but it's actually a lot more about the topic. It's like a much broader topic that we're going to cover. It covers processes, it covers people, it covers the journey as an entire thing, and covers the whole map and point on and the different views on it that we are going to try to get to. And like I said, we only have an hour to do that. So after the session, I'm more than happy to hang around if you guys still have times, and we can take it more interactive. We can get to more questions. But this is the agenda that we have for now, and I'll try to get the best out of that. So first of all, you guys probably know the basic cloud drivers. Why do you decide to get to the cloud in the first place, right? It's not a 2012 anymore. I've been actually working with the cloud since 2010, so it was like a lot different in the early days. And like in those times, Azure had 5 features, and not everybody heard these type of reasons why I should migrate. I believe in 2021, everybody heard that. So whether it's like the capacity need that you have, whether it's compliance or anything that you would actually like to leverage in the cloud, or your data center contract expires and you would like to get more flexible, all these kind of basic things are there. The thing that I really like, what the reason for 2020 or 2021 is, I really like the security threats, like the security reasons. Because in 2010, when you asked someone, why are you not going to the public cloud? The answer was like, yeah, we have like security concerns. We don't trust the cloud provider. We don't trust the cloud vendor and everything. And nowadays, when we have a lot of different ransomware and other security issues, there's a lot of folks actually moving up to the cloud because of that, because you can't really fight the wars of today with the 19th century canon. So I really like that one, and seen a lot of customers moving for that one. But whatever your driver is, the initial moment is there and plenty of folks are moving. You guys gonna get the shiny new data centers pretty soon, right? So whether you go to those or whether you use some of the existing ones, all the motivation is there. I'm not gonna spend that much of a time on this slide because I believe in 2021, everybody heard the reasons for that. We can elaborate on those a little bit more if you like to. Now, Gartner actually describes the way how to migrate to cloud in a 4 or 5, depends how you count the different things. So basically, let's say that we are decided we are moving up to the cloud, and then how are we going to do that? How are we going to execute it exactly? Now, plenty of companies, and I would say like 90% of those, are doing rehost first, right? So they take what they have in existing data centers, mainly running on VMs. They do a lift and shift. So they take the VMs, they migrate the data, and they put it up in the public cloud somewhere, and they run it and continue to run that as VMs, right? So that's a useful first step. Now, plenty of companies do the mistake that they're not making it the first step, but they make it the only step. And that's what we are going to talk about today, how we can get from that first step to really be a first step, and how we can continue that journey to get a little bit further ahead of that, and how we can utilize the cloud to the fullest. So there are another possibilities how to leverage that, how to leverage the cloud benefit. And that's a refactor, how we're going to turn our applications into something a little bit different to actually leverage a bit more of cloud. So you can still start on VMs, let's say, but you're going to give it a little bit of a cloud favorite. Let's say that you're going to use the more cloud native networking elements, and there are some site recovery options for better availability and better zone redundancy. You can throw in stuff a little bit around backup and things like that. Maybe you're not going to need a full-blown server for this and that, but you're going to go for a service instead. And that kind of goes more and more into re-architecturing things. So you already leaving the concept and you start basically to swap components around. And perhaps on the way there, that you basically find out that some of your components are not really fit for re-architecturing. There might be basically more fit for rebuild. And that's where the code comes in. That's where the new approaches comes in. That's where you basically start to more of an advanced journey, how to optimize your your architecture and your things that you're actually running up there. So we're going to cover all of these today. We're going to go through all the steps. There's actually like the fifth one that Gartner mentions, and that's a replace strategy. So basically, you're replacing something with SaaS. Maybe you don't even go to Azure. Maybe you just replace that with an application running from somewhere else, or potentially even Azure, but it's run in a pure SaaS way, basically, and you will just consume that. You don't get to touch it. You don't get to fiddle around with it. You don't get to poke around the code, which might be boring, but that's the way how it is. Like there's plenty of things that that folks are replacing with SaaS. And when I turn it around to companies like ours, we develop things to run as SaaS for our customers, right? So that's the way where everybody kind of is heading to. And whether you are there, whether you want to replace things with SaaS, whether you build SaaS, or whether you basically just want to modernize different bits and pieces, we're going to have everything for everyone here, just a sneak peek into how you can actually do that, what components you can choose around, and what strategies you can implement around that, wherever you are on the journey. So how do we get there? Like we said that we're going to migrate some of that stuff, but first of all, we need to really discover what we have. That's like a first sort of pattern that happens around any company that migrates or decides to optimize already migrated stuff. Like first part is discovery. So basically you going through the list of your VMs or physical servers, of your virtual networks, whatever networking elements you might have, whether it's firewalls, load balancers, and things like that. That's like a technical discovery part. So you need to somehow map the cave, if you will, and see what you got, and if you taking it with you, in what shape, and how long it's gonna take, and everything. Now there are some not so much of a technical parts along with it that might be more of financial, if it makes sense, like if it makes sense from a return of investment kind of thing, or total cost of ownership kind of thing. These are things that go along with it and are part of that discovery. So basically, how high is my bill going to be when I migrate this thing over? There, of course, discovery should be also around the dependencies and the roles that you have. So if I migrate this server that's running my CRM system, let's say, it's probably going to have some dependencies on domain controllers and databases and whatnot. And it can be a lot more granular than that. It can go into like the dependencies on the different technologies, different frameworks, different type of databases, things like that. So it's important to discover all of those. It's important to map these properly before we trigger any migration or optimization for, let's say. Now, the actual migration is quite easy, or whenever I say that, I get slapped with some sort of karma or universe revenge, but you know, like it's not really the rocket science for its sake. Like you prepare the prereqs from networking kind of things. Some of the prereqs are somewhat unique to cloud and Azure environments, where you fiddling around identities and role-based access control, resource groups, and the way how you're going to deploy in the future. And once you figure that one out, you basically like take what you have in those dependencies that you have, and you're going to replicate that, deliver that over to a public cloud provider, and you probably going to end up with some VMs. From that point, you can already optimize like a little bit. Even before you actually trigger the migration, you can already optimize some of that stuff. So it doesn't have to be VM all the time, right? Like you can already, for instance, plan for something more scalable that kind of honors the pattern of VMs, but it runs a lot better. So there are, for instance, VM scale sets. You have like multiple instances of the same VM, and you scale horizontally on that level by replicating the same type of application running on that same type of VM, but you are capable of leveraging some of the more cloud native capabilities of that scaling. Because it intelligently places those things behind the same load balancer. It's leveraging some of the cloud components in terms of scalability and predefined sizes of that, and takes pretty much care of the half of the thing that you provided. There are some other ways, other smart ways how to, for instance, keep the dependencies of the SQL Server, but running it more as a service on, for instance, managed instances. So you can leverage basically having a database on a managed SQL without going a full-blown SQL before you manage to optimize to something better. There's a plenty of things like that that you can leverage. We're going to talk a little bit more about those a little bit later. Now is the optimization part. And that's how we're going to move from VMs to services. And that journey goes through containers and microservices and different platform services, perhaps like DBs and app services that you might find out, but plenty others as well. We're going to talk a little bit about those and how we find that proper journey to those. And the most important thing is that the optimization part, that's ongoing circle. That's not going to end, basically. Like I'm pretty sure that anyone who works in IT consultancy, and I used to work in a consultancy, they have a pretty safe job, right? And because we keep migrating stuff, and optimizing stuff and replacing this and that with whatever newer technology comes around. And I've seen, for instance, customers who asked me like, "Hey, I upgraded, I just like migrated everything to Service Fabric, and so I'm done, right? I don't have any more job to do. Basically, it's awesome. Like I'm running on Service Fabric, and suddenly Microsoft announced the Service Fabric mesh, and they were like, "Hey, so do I need to like migrate again?" You know, you will constantly get these kind of questions and considerations. Some of them might be relevant, some of them might not, but I'm pretty sure that we will optimize things till the end of our days, and someone's going to take it after that. So first of all, where to start the optimization? Well, plenty of companies actually start the optimization from the cost. That's usually like the first driver that kind of forces people to choose the size of workload, right? So the kind of a problem is that developers and IT folks, they were not necessarily exposed to the reality of the cost before that. They just it was just somebody else paying the bill, and their actions didn't necessarily had the consequences of changing the bill that instance. That's very different in a public cloud environment, right? So if I change the SKU of my VM or whatever service I use, and that very instance, I get to pay more or less. So it's quite convenient, but it kind of goes both ways. If you get people choose what type of a box they need for their workloads, they will somehow always end up with the biggest possible box, or at least the bigger one than needed. So bigger t-shirt sizes or bigger box sizes, they will always end up with those, because like, what if there will be somebody coming in and some spike or something, whatever, that we might actually need that. And we're fighting those kind of things all the time. Now, this is exactly the reason why we go to the cloud in the first place, but perhaps the VM type of architecture is not the best one to leverage cloud capabilities of scaling, because we keep having the same size boxes around our workloads, and maybe they might be bigger boxes or smaller boxes, but there are still boxes, right? So first of all, we now have this confrontation to the IT folks or developers by choosing that box and associating with the cost, right? So it's kind of important to allocate resources properly. You might have bigger boxes, you might have smaller boxes. The importance of resource allocation is just there. And sometimes I walked into a customer's environment and it looked like kind of like this, like the resources weren't really properly utilized as they should be, or they had a lot more resources that they could leverage. Both of them represents an issue. So basically, the cost optimization is a continuous process. Whether you start it and get some results out of that today, you probably want to keep a track on that for a future as well. So basically, that's where application teams and IT folks and everyone comes together with the management and finance. And the ongoing circle basically looks like this, right? So you start for some visibility aspect to it. You would go through your Azure subscription and see how much things currently cost. Now, plenty of folks actually start that step, or they use like Azure Cost Management or Cloudin or whatever tools there are out there, or they just go through the spreadsheets, and actually they just take it from there, and then they say like, okay, so we have these things and that things undersized or oversized. and they straight away start the optimization. The problem is that they will end up in the same problem sooner or later again. So what plenty of companies actually forget doing is to hold people accountable for it. So it's not just the infrastructure that you deploy, it's not just the piece of code that you deploy that you are accountable, but you're kind of accountable for a cost as well, because that's the thing that brings along with it. And that's not a problem of IT alone, for let's say. It's pretty much an issue everywhere where you have some cost associated with something that people didn't really have to care about before. So I have a friend of mine, he works in the movie industry, and he works on the special effects that they need to render. And the rendering of those special effects actually takes up the lots of graphics cards, right, that you can imagine that. And they have pipelines similar, like we have CI/CD pipelines. They have a release pipelines, actually, like what goes to that farm of graphics cards and how it gets rendered and when it goes away and frees up the resources. And before they got the requirement from management to drive the cost down, nobody cared about how those graphics cards are actually utilized. And suddenly the requirement came and said, like, hey guys, you need to drive your cost down by 20%. And suddenly they start to optimize the pipelines, and suddenly they started to actually hold each other accountable for basically utilizing that pipeline. They say, like, hey, your job takes a lot of time. Maybe if you would optimize it properly, and it would free up the resources for other folks, for other queues. And that's how you get from visibility to accountability to the optimization. We kind of need to do the same thing. And then it's a lot clearer what needs our optimization and how we can get there. Now, how do we perform that optimization? So what do we do now, right? Like, we covered the cost, we covered like the basics really. What really happens next? Like, how do I get from my expensive box to something better price-wise and architecture-wise? Well, it's kind of a question, where do you really see yourself? This is the most annoying slides from all the cloud presentations, right? So basically, like, everyone's seen that at some point. Everybody knows what it is. Doesn't matter what cloud vendor you went for a presentation, they always had this slide. But it's kind of important to see where do you really want to see yourself, and what type of things from those boxes you really want to manage. So do you really want to manage everything from the operating system up? Do you really want to manage even like the dependencies from a runtime type of things? Like, you need to make yourself these kind of decisions and and considerations. I will put this one away because we will go through that, and like I said, it's an annoying slide, right? But with a big cargo comes a big responsibility, and it's not always the easiest. So this is your monolithic application, right? Like, if you have this type of application that only goes with a VM, then you need to constantly manipulate VMs, and it's not always the easiest way. So how do we get to something smaller? Well, you might heard a lot about containers. Containers perhaps are not always the answer, or at least not the definitive answer. Plenty of folks go like, oh, I have containers, it's all taken care of, right? It's just, that's what we do, that's where we are. It's super cool, I heard it. And yeah, that's how they end up. So we're gonna take it a little bit further than containers. It doesn't mean that one thing is necessarily better than the other one. It's more about your workloads and your consideration that you need to make. It's perhaps like to realize maybe you don't have to stop at some point. Maybe you can continue one step further. For something it might make sense, for something it might not. So we're going to like into like smaller packages that are easier to manipulate. Like, altogether, they might create a big chunk of things, but it's easier to actually handle those in the smaller packages. And you've seen the big warehouses; they work quite efficiently, right? So how do we get there? Well, first of all, we need to break up the monolith. Our monolithic application that we have that sits on that VM and goes with the VM, because you can only scale the VM by cloning that VM. It's not always working out, right? The VM has a lot of dependencies, whether it's inside the domain or whether it's a lot of things that drags along with it. It has a long deployment times and everything, and it's like we discussed in the beginning, it's quite expensive. So how do we get to that? Like, it's easier said than done, right? So basically, you've heard at some point that you're supposed to go into microservices, right? Pretty much the same as buzzword as containers is. Like you go into microservice-based approach. And how big is that microservice really? Well, about this or that, or maybe smaller than that. It kind of depends, right? So basically, let's take a little step back into what we really need to do with monoliths and how do we get to something else. Now, the trouble with monoliths is quite obvious, right? Everything is tightly coupled. Everything goes together, updates the same way. What's even worse is the entire delivery cycle that you have around updates. So since it drags along that many things together, then you probably have a not so short of a cycle where you release these things. And we kind of saw that in some of the applications. I saw it with my customers as well. Before that, we actually had like a lot of different monolithic type of applications, and the life cycle was around half a year or even longer before, because the builds took really long and everything before it got tested all together, before it got delivered to different customers, before they installed it themselves, everything was like a very long procedure. All the components got scaled in a very similar pattern. So basically, how do you scale a monolith? You replicate that. So it wasn't that cost efficient. And basically what we are trying to achieve there is the opposite of that. So we try to go into the smallest possible packaging as imaginable. However, we need to kind of think about what these things do. They usually perform very well at one thing and one thing only. And that should be really the key. Like they basically should be like independently manageable. They should keep the code and the state together. And basically it should be possible to deliver those in those individual bits and pieces, right? So basically, like that's how we think about microservices. We think about the different tasks, perhaps. We think about the different modules that we have. Anything that is like very loosely coupled, and that can be independently sealed and packaged. So that's usually another definition of the decision where we think about like, hey, what should we put aside maybe, and what should be like the first things to isolate. So it can be your messaging queue, it can be your database, it can be smaller chunk than that. It could be what happens when you click that one button. There's no good universal answer for that. You can take a little bit more time after the slides, perhaps in your detailed discussion, but there's not a universal answer for that, really. If you came for looking at one, I have to disappoint you. It's very much individual to every project or everything that you will go through. Now, why do we even doing this? Like we said that we're gonna reduce the cost, right? So with the higher density, we can actually pick something else than a VMs to scale. That's the first thing. It's a no-brainer, right? It's we're gonna scale basically these things. But cost is one thing. The obvious cost from Azure. That's you're gonna get a lower bill from your cloud resources. That's a nice one. But it also kind of helps you to be more efficient in the entire developing process. And it goes the other way around. You need to get more efficient in your development process before you end up doing microservices, right? So the culture around that is a lot different. You're going to deliver more and you're going to deliver faster. You're going to basically deliver a lot more smaller pieces versus the one big monolithic chunks, right? And you're going to deploy them independently from one another, not necessarily the one massive chunk that you've been doing before that. So how do we get there? How do we get to this procedure and basically like what we need to get going in the first place? There are several models that we need to consider, right? We already tackled a few of those. Now, the first one that we're going to talk about is the cloud infrastructure ready. And we're going to get our way all the way through like the cloud sort of native things. So cloud infrastructure ready is that lift and shift that we discussed, right? You can have that in the existing .NET application. Usually it's like a client server type of thing. It comes with the thick clients. It comes with a database, basically it's simply to rehost that stuff into Azure like we discussed. It can be .NET based, can be whatever base that can use whatever relational type of databases you might be used to. That's our monolith that you're going to take apart, right? So basically, we said that we can leverage VMs for that. We can use the managed instances. We're still keeping it monolithic though. Now, the pros of that are that there is no re-architecture. You can really get yourself going in the cloud fairly quickly. There's rarely need for any new code. Basically, like if it runs on the VM, it's gonna run on the VM the same way as it ran before. Very much of low effort into get things moving. Also, you might have things that are perhaps legacy, that are at the end of life. You might need to like extend yourself a little bit of a lifetime by providing support for things that are out of support on premises. You might just want to kill it later on. You might refactor it in the meantime. Pros are quite obvious. The cons are quite obvious as well. They're basically like something close to nothing of a cloud value of that. It's you're running something in the cloud. We discussed that from many different angles. If you run this thing from on-prem the same as you were running on-prem, and if you run that thing in the cloud that way, you're gonna have very high bill, probably higher than you had on-prem. You're gonna have very low type of value. You're still gonna manually patch these things. You're still gonna have to take care of that. You're still gonna have to basically like take care of the scaling and everything in there. So how do we get to something more like that microservices that we discussed, right? So we need to talk about the cloud DevOps already. And that's more of a basically like procedure change than it is really necessarily a tool change or basically like a technical type of thing. So the good thing is that if you are going towards containers per se, there's not that much of re-architecturing or that much over new code. Like that's fairly limited, right? It's pretty much like still keeping up the dependencies. It's increasing the density, but it's basically like sharing a lot of underlying components from the stuff that we shared before. We might need to have some high availability considerations, and that's where we will talk about a little bit about container orchestration. But basically, like if you heard about Docker, if you heard about containers, I'm pretty sure most of us did at this point. This is the way where we go. Now, before we get there, there's a kind of the elephant in the room, and that's called DevOps, right? And everybody was like DevOps that and DevOps this, and everybody talked about some different flavors of DevOps. So you might have about DevSecOps and whatnot, and basically like everybody is kind of talking about that. And there's a lot of misconceptions around DevOps as well. So basically, the simplified version of why we need DevOps is to bridge the gap. Because otherwise, there's always going to be the gap between the IT folks and the development folks. And I've seen plenty of companies who basically said, we do DevOps. Yeah, we have that. And then I met their development team, and they were like developer guys sitting on one side of the table. And then I met their operations team, and they sat across the table. They were talking about each other like, hey, those guys, you guys did, and we guys didn't do this and that. That's not how it looks like from the start, right? So basically, like, we try to bridge the gap between those two folks, because they should really sit as close to each other as possible and work on the same thing and deliver things in a way together. Now the reason why containers are in that equation, so is nobody can say like it works on my machine, right? So it's someone else's problem now. Like, hey, like it worked on my machine and someone else need to take care of that now. That was kind of a classic approach before DevOps, or it's an approach without DevOps. So somebody deploys a piece of code and someone else needs to take care of that. Someone else is responsible for how it runs versus someone else is responsible on how fast it's got to place. So that's what we tried to change in the first place. With containers, there's no such thing as it works on my machine, because it works on everyone's machine. If you have the same container setup, if you go with the same Docker file, if you go with everything like that, and basically it takes care of all the dependencies that you have described in that Docker file, right? So it really helps you out to automate things like deployment because you have it described in the Docker file. You can run it on anything that basically runs that type of implementation. So you basically like don't care about the prereq sort of setup, and you just need to do a little bit of exercise regarding those deployments, right? So first of all, for those who haven't seen containers ever in their life, and there are still folks like that, so you don't have to feel ashamed if you do. It's pretty much like very simple. Like compared to the traditional infrastructure, we had our infrastructure, we had operating system on top of that, we had hypervisors, and then we have like guest level VMs in the virtualization world, right? On top of each of that virtualized machine, we have some binaries, libraries, dependencies, whatever you want to call that. Then we have our application. Now, in the container world, we just go a step lower, I would say, and basically on top of the operating system, we have container engine. That's where we run our binaries and applications and all those dependencies. Now, it's a little bit different from the virtualization because we don't necessarily run isolated copies of those VMs in a truest of sense. They are isolated, but they are still very much dependent on the underlying operating systems and the container engine. So if the host OS fails, then the containers fails as well. While the VMs, we might be able to live migrate somewhere or do something around those. If you remember the early days of application virtualization, this is pretty much the latest and the greatest that we get from there. But it was always somehow there. People always try to virtualize the applications and virtualize the dependencies of those. And this is how we get there today. This is like very simplified way to look at it. So basically, if we say that we have a new sort of way of isolating things, but we still have like a constraint on the operating system, then we somehow need to make things more orchestrated in case of failovers, in case of the disasters and things like that. So first of all, how we get our existing stuff into Docker container? Well, since Visual Studio 2017, there are Docker-related capabilities. You can it helps you generate Docker files. There are some of the useful tools that can help you out of that. There's also IIS and ASP.NET tools. Those will help you to generate Docker files out of your .NET apps. There's a Docker, there's an image to Docker tool, a PowerShell command line tool, and there's plenty of other things that will get you through it. Lots of different migrations assistants that will help you out. Now let's say that we actually deploy the container, perhaps to Kubernetes, perhaps to somewhere else. It's another buzzword that you might hear. So basically, we have our development environment. We have the containers running in there. We need to push the code somewhere. It's probably what you already do. You push it into a repo, whether it's GitHub, whether it's in Azure DevOps, whether it's someplace else. That's where you go. You push the code. You build your stuff. So that's basically the continuous integration part. You can again like build it in Azure DevOps. You can build it in using GitHub Actions. You can do a lot of things. And then you get to push it in you get to push it in the image state. You basically like you have that image out of that build part. You get to push it into a container registry. That's where your images live. And you can either do the public one, which is Docker Hub, or you can do the private one, which is Azure Container Registry, for instance. So that's what lives inside your subscription. You have existing role-based access control to that. Now you get to deploy that stuff, which is part of the continuous delivery process. And that's where it takes care for. And basically the pro is like into the selected flavor of container that you might have. That might be Azure Kubernetes Service. That might be Azure Container Instances. It might be Azure Web Apps. Lots of things in Azure support containers now. Now, the big question is, if you like really need orchestration for that, or if you run containers as a standalone. We will get to that a little bit later. But basically, most important thing is that even IT is transforming in that way. meaning that the IT guys no longer need to be a clicking monkey for that thing to say, but they have to run a lot of things inside a code that doesn't necessarily resemble the code, like ARM templates in Azure or templates of any kind, or any kind of scripts, and even like delivering these containers. I'm not going to spend that much time on this one because it's a very high level thing to do. Now, basically, the only con of the containerization is that's additional step in the learning curve, right? That's not everyone needs to be ready for that. Maybe you are, but perhaps the guys sitting in the IT are not. Perhaps one of those teams that you are working with is not. And that's really how it goes. Like usually it's not the entire company who like jumps on the transformation straightforward and entirely. It's usually like one more progressive team that drives that, and the other one are going on board, or it's like one solution inside that team of yours that makes sense to modernize that way, and the others will take it from there. So basically, like, find the thing that makes sense to do it that way, and just do it, and help the others to establish the processes and establish the way how you talk with people around that, and that will get you going on your DevOps transition into that. Once you're there, a lot of things happen after that, and a lot of things allow you to happen after that. Now let's talk about a thing which is cloud optimized, which is maybe further ahead than a containers. So we talked about containers, and I mentioned that you can run those inside the web applications and different things, but perhaps it doesn't have to be a container, for instance. It might be beneficial from a lot of different aspects, but you might perhaps go straight away into functions. Perhaps you've already been there because it's such an easy way. Plenty of people go to functions just because they are way too lazy to manage the other things. That's a different story. But you can pick and choose the things that make sense for just that one purpose. Perhaps you need just a messaging queue, and you go into Azure Service Bus. Perhaps you need just a function. You need just the web app, and you combine all these things together. And it makes perfect sense. So this is basically very much optimized for the agility. You need to really have that process established already that we discussed for Cloud DevOps ready. But it kind of rewards you with that scalability, because you can really scale those individual parts completely independently. You kind of have the separated delivery process already built in because they are different services. And that's the microservice sort of based approach that you can leverage to that. Cons of that approach is that perhaps it's not that useful for starting with necessarily, because it requires the refactoring or rewriting, and that might not fit with your time expectations or budget expectations or your expectations entirely. So there are things to consider. Of course, this is a great place to start with something new. But if you're going through the refactoring and migrating work, that this is probably a place where you will end up with some of these things, but maybe not all of them. So it's kind of up to you to decide that. But this is where the road ends. This is where the road goes, and this is what we're gonna end up using anyway. So basically, the journey in the fairly high-level slide to basically recap that is that you take the stuff that you have, you rehost that, go through the refactoring, and possibly re-architecturing it, while building the new stuff as well on the side. Maybe some of that you will replace with SaaS, but building the new stuff is towards better cost efficiency, whether it's through the containers or application platform sort of things. And you kind of have to build the processes on the side of that as well. That's a kind of high level journey of that. Right. So it seems like you're ready to that. We kind of have this road ahead of us. What else do we need to consider? So there's a lot of things that you don't have to really manage or basically build from scratch, right? There's a lot of things in Azure that you can leverage even if you run on VMs, and start from that point, like manage identity part, you have Azure AD domain services instead of your domain controllers, and that's your managed domain that you can leverage with some restrictions, of course. When it comes to all the managed services, there are always some drawbacks, but you can start with that. There's a plenty of things that you can leverage on that one, and not having to maintain or patch domain controllers. From networking perspective, I would say that that's usually the part that's actually the easiest to begin with, because you have so many things on networking that you can just pick that you don't have to build, like load balancers and firewalls and application gateways, web application balancing. Whether you're using app gateway or front door, these are usually the most kind of forgotten things in Azure. But there are great things, even like the Azure DNS, which kind of don't get all the fame as it should. So when it comes to the fast scalability, you kind of need to think about the DNS as well. And plenty of people basically like run the DNS somewhere and run the rest of the things in Azure. And then they are surprised that the replication of DNS records take a really long time, and it's not always up to date with everything. And you need to like maintain these things in two different places. You need to go to your DNS provider, and you need to go to Azure. Why not having everything in the same place? Why not having your DNS records as a part of the same CI/CD pipeline as you have delivery for your other things? So it's really easy to start from the networking things. And even if you build multi-tenant applications, it's really easy to actually start from networking part as one single endpoint that your customers hit, and get redirected to a bunch of different things after that, whether it's through the front door or through the web application firewall inside the application gateway. So there's a lot of things that you can come up on that level. Now, to start, label and report everything, whether it's from financial perspective or automation perspective. Establish yourself policies for for labeling stuff and basically like putting stuff in the right places. It's more into the governance sort of topic, but it's really important, not just for understanding your Azure build, but for moving forward as well. It will help you to discover things. It will help you to basically like see if things are utilized the way you expect, or if they behave in any strange or non-standard way. Always think about things that you need, and if you need to build it yourself. Like, do you need a web server, or you can go somewhere higher? So I meet plenty of folks who always tell me like, yeah, but we really need to have the IIS server because we have so many dependencies on the operating system that app services don't handle that. Well, maybe there's a mid-step. You can run containers in the app services, even on Windows containers, and that could give you like those dependencies that you need, but you can still run in a more scalable package, right? So there's always a mid-ground. There's always like things to consider, and stuff that you don't have to build. Like I've seen people running the different things on the file shares on the VMs because they didn't know about the Azure files and Azure storage. So sometimes there's like either no refactoring or very little refactoring to get a lot better results with cloud native services. So think about those if you really need to build stuff on your own. That kind of goes into another things, not just the web server, but there's a lot of things for reporting, like Power BI embedded. There's a lot of things how to read things from sensors and whatnot. So even for guys who are like further ahead, who, for instance, already run everything on Kubernetes, you often see them building stuff that they don't really need to build, like a time series or gathering the data from the sensors and reporting those and things like that. Now the great part, which is actually there and often gets built unnecessarily, is for instance in logic apps or in functions. So I saw a lot of company different logics built in a lot of different things, and those teams were saying like, hey, we actually need that VM. We can't get rid of that because it holds the entire orchestration procedure that we have, and we can't rewrite it because we don't have resources and whatnot. So we went through that, and I was asking, so what's the logic? Oh, well, basically, like we have the files on this file server, and when the files gets received, it gets processed and it gets something modified in that, and it gets uploaded there and there, and it gets also registered inside a database, and it then moves to that one, and it creates a reference in that system and that system. It's like, okay, let's try that. So basically we try to do the same logic with Azure Logic Apps, and it's like very visual way of doing things. And whether you decide for logic apps or functions, you can leverage the same type of connectors. And we were able to recreate that logic in just a couple of days, really, because suddenly you could have talked to legacy APIs, you could have do the things that you've done before. It has a lot of connectors, a lot of integration that you can do. We were able to get rid of a VM. So sometimes the answer is not straightforward, but there are definitely tools available that kind of help you out to do that. Now you can also leverage the things that you perhaps weren't leveraging in the public cloud necessarily, because you didn't have the capacity for that on premises, or maybe you didn't have that much of a considerations or that much of a time that you were paying attention to that. But you can do a lot of things with machine learning and cognitive services. Machine learning is like, of course, like a topic of its own, but inside the cognitive services, there's a lot of things pre-built, like the image recognition and and basically like custom learning service for tagging your pictures, things like that. So once I worked on a project where we gather data from CCTV footage, like from all the cameras around the property, and we hooked it up to video indexing service in cognitive services. At that time, it was called Project Oxford. And suddenly we got all kinds of different perspective into the video footage that we had, right? The customer had at the time. Because you didn't have to go through all the minutes of the video footage and look for potential security issue or potential stuff like that, but you could have just do a natural language search, like show me a guy in a black coat. By the way, funny thing about cognitive services was that when we hooked it up the video to that, it was labeling lots of different things that we had no idea about. So for instance, it told us about all kinds of different birds that lived around the facility, and it actually named them. So we didn't really have a clue that those kind of birds are there, and they are there frequently, or what their names are, but it really helped out. So add some business value with services that you perhaps weren't been using before, because that would be like a scalability issue or a type of performance issue. You can get these type of services by paying per API call. So get those when you can. And basically keep in mind that DevOps or any sort of cloud transformation is combination of not just tools that you use. I had a customer and he said like, oh yeah, we do DevOps, we have tools for that. It's not really right. It's a combination of tools, processes, and people, and all of that needs to come in together. And that mindset change in people in terms of doing stuff more frequently and doing stuff in a different way and not thinking about like, hey, it works on my machine, is sometimes the hardest one. But when it all comes together, that's where you can really get going, and through basically overcoming the initial difficulties, go more into the standardized process. And with that, we finished our high-level journey. And if you have any questions, I can still hang around here. We can go perhaps a little bit more into detail into other stuff. But thanks a lot for your attention. And like I say, if you have any questions, feel free to come on mute and we can talk about stuff.
Thank you very much, Matouš. It was really great.
Thanks.
You guys, feel free to ask. Don't hesitate. If I may ask, okay, yeah, of course.
Hello, Matouš. Thank you very much, first of all, for the presentation. I would like to ask about, let's say, hybrid approach. I know that a lot of government organizations are they are afraid of moving to the cloud. So we are starting to see now some of their services being moved to the cloud, but still they would like some other services to be in their own data center. So what's your opinion on that? Do you think this is viable? Have you seen it?
Yeah, of course. Like we work in energy business, right? Which is probably the one of the top sectors that tend to stay on premises or have some security risk as assigned with it. Like if you go instance into the nuclear power station, that's usually not the guys who are considering cloud stuff per se, but at some point they gonna get there with some services. So basically, like first of all, there's an important differentiation of whether the requirement to be on premises or in the cloud is really valid type of requirement. So I've seen a lot of people who use that as a first excuse why not to go somewhere, why not to do anything, and they always say something like, "Hey, security will never accept this," or basically like our security is really tough, so you don't stand a chance with the cloud, and things like that. And when I ask about things like, okay, show me that particular requirement, or basically like let's talk to those security guys, let's review those security documents that you have. Usually some of those requirements go away. That's just how it happens. Now, you might actually have a lot of things that need to stand on specific country soil for privacy reasons or whatever others. I believe that is being overcome by many regions being opened in specific countries. So we got data centers in Norway. We are waiting for data centers in Sweden. You guys gonna get data centers in Greece, and more sovereign clouds are being built. That doesn't necessarily always mean that it's going to be the best possible option, because those sovereign clouds usually come with a higher cost assigned to it, and they usually come with less services available. So perhaps it's not going to be for everything there. But it's still a step in the right direction. And the third possibility of that is that there's a possibility of running things on the edge, or more like in the hybrid cloud model, like you mentioned. That hybrid cloud model is a lot different than it used to be in 2012, right? So basically, like, people still have that vision of hybrid cloud means that I have my VMs both on premises and in the cloud. I keep trying to convince people that the VMs are really not the best way of managing things, but perhaps you can manage things through the same containers kind of approach. You can have Azure Arc, you can have containers deployed locally, you can have containers deployed on the edge when it needs some compute power. You can still manage it from the same pane of glass. So basically, there's a lot of midpoints and mid steps in going into the right direction, and it's about right combination of things. So perhaps the things that don't have any privacy considerations or issues can go to the cloud straight away. Then you have some things that might require some work, so it's up to you to evaluate if that work is really necessary or where it can run. Then you might have stuff that are not qualified yet to go to the public cloud. And in the meantime, before you get the sovereign cloud, or before you get all the security certification that you have, you can have it on premises, but with cloud type of management like Azure Arc or similar, where you can leverage that. So I would say do the kind of homework, again, like go through discovery, like we discussed in the beginning, and label your stuff, label the stuff that can go there and there, and then see what you can do about that.
George, everything okay?
Thank you very much.
Yeah. By the way, George is we were together in Prague last year. Matouš is the friend of mine. Remember?
I remember you guys. Yeah.
Any other questions, guys?
Don't be shy. Maybe I'll have a question. How is it in Greece, guys? Do you have nice weather right now? We have lots of snow here.
It's very cold, not snow, but very cold.
So how is it like very cold in Greece standard?
Around zero.
Actually, zero, yeah. And
okay.
actually, we did have snow in Thessaloniki over the weekend. It was just beautiful, but it was not as cold as I imagine Northern Europe to be.
Yeah, I can imagine that. I haven't been in Greece a long time, actually. It's almost 11 years. I really miss that. If that would be like physical meetup, I would totally come. I really like it there. So kind of regret the whole situation, but yeah. Last time I've been to Greece, actually, I presented the passport at the front desk of the hotel, and the guy looked at my last name and he was like, "Oh, you speak Greek, right?" And suddenly started. I was like, "No, not really." And like it's a Czech passport. I was like, "Yeah, but that doesn't matter. Like plenty of folks like lived in Czechoslovakia, Czech Republic at the time. I thought you're." So that's how I found out that apparently my last name is somewhat common in Greece, I guess.
There's a rock star called Rokos.
Exactly, it's the
pop rock
surname of
star.
a singer,
Yeah.
a very well-known one of that.
Yeah. So Matouš, what's the most common way that you've seen in migrating to cloud? Still, things are going only on migrating VMs, or people are adopting the platform as a service way that you showed and the cloud optimized way?
They definitely do. It's sort of like a divide and conquer way. Like, so you start from that labeling basically, and you see what you can do. And that's a great place where to start already picking up the parts that you can optimize straight away. So perhaps you don't have to like move them at all into VMs if time allows, and you can start working on these things straight away. If the time pressures, then what I saw is usually that lots of things end up on the VM as a hosted solution first, but perhaps you can do something around how you actually run that thing. So you can perhaps already provide it as a service, because if you manage things well enough, then customer won't like notice a difference. You can automate a lot of things about deployments. You can use ARM templates. You can use whatever flavor of automation that you are comfortable with. You can have it in PowerShell scripts. You can have it in a chef recipes, Puppet,
Terraform.
Terraform, whatever you like, exactly, Ansible. Yeah, lots of different things. It's not just about how you get the stuff inside the Azure services or other services, but also keep in mind the stuff that you need to go inside that VM if you actually run it as a VM. So like VM extensions using, again, like Chef or PowerShell or even containers delivered inside those VMs. That's another mid step that can be used. And yeah, but just start to label things really, and then see what you can leverage on a VMs and what you can put together maybe in a more cloud native way, and maybe something that you can start re-architecturing straight away.
Thank you. Cool. Any other question, guys?
Maybe. Go ahead.
Sorry, somebody wanted to ask? No, I think false alarm.
Maybe I'll turn it the other way around. Like, did you guys see any increase in demand when the new data centers get announced? Like, do you get any more projects, or do you get any challenges in existing projects when it comes to migration and modernization?
Probably there will be, if I may answer, but I don't have the overview yet, but I think it's going to increase all the cloud related projects. I don't know, George asked something about security, etc. There is one thing about GDPR that the European Union is a bit sensitive. I don't know if this is going to be any obstacle, but other than that, I think there is no way back.
Yeah, the GDPR actually is quite interesting, because it's if you remember, like one of the first slides that I had, like why do people migrate in cloud? Actually, the GDPR is one of the reasons why actually people do migrate in the cloud, because it's a lot easier to track the compliance on the cloud level. Because like same as when it comes to networking and other things, like it's a lot easier in the cloud than in on-prem, because like when you take it from a, let's say, hacker approach, and you go to on-prem and you end up in some networking segment, the first thing you kind of have to do is to map the cave and see where you are, what subnets you have available, what they are routed with, where you can go, things like that. And in cloud, you do a couple API calls, and it kind of shows you what networks you have and what's the subnet range is and what it's linked with, and you don't have to do the necessarily the full-blown IP scan and port scan and all that kind of stuff that you have to. And in compliance world, it's a lot the same thing. You have pre-built compliance tools in Azure SQL databases, for instance, or other type of storage possibilities in Azure. You can straight away do the search for credit card numbers and basically social security numbers in the different country formats. You know, it's a pre-built stuff that Microsoft built for themselves because they, of course, need to be compliant with the GDPR as well. So why not reshare that with all the customers, right? So I actually have seen plenty of companies moving data to Azure to be compliant, to get the access to get to those compliance tools, rather than having audits in their on-premise systems and having hard work in their on-prem systems.
Yeah, that's a good point. Many people don't really know all these details, and they think it's going to be hard to migrate because of GDPR, but yeah. Okay, any other questions, guys? Okay. We have something in the chat. Is it possible to?
Where is
Okay, no. The question is if your presentation will be available. I think, is it recording? Yeah, I think we are recording. So if you're okay, we can.
Yeah, absolutely. Feel free to share the recording. I'll let you go with your evenings if you don't have any more questions. But if you do, like, feel free to reach out on LinkedIn or Twitter or wherever, and we can take it from there. Otherwise, thank you very much for your attention. It's been great.
Thank you very much. It was a great presentation, and we hope next time we'll have you in person in Greece.
I'm hoping for that as well. See you around, guys.
Thank you very much. Bye bye, guys.
Thank you very much.
Bye bye.
Thank you very much. Have a wonderful night.
Thank you. Have a nice night.
Bye.
Bye bye bye.